from graphs, and we're doing things algebraically. We're going to be calculating limits algebraically. Thank you. Bless you. Hey. So like I said before, calculus deals with algebra, geometry, algebra 2, statistics. We're going to be working on all that. So now we're moving on to the algebra portion. So today is the 25th. And we're working on computing or calculating limits algebraically. All of our notes today are going to be in our notebook. I know that usually I print out the example sheets, and then we write the answers to the examples on the example sheets. But because today deals with a lot more math and us working things out, we're going to put all of our examples in the notebook, but you still have the example sheet in front of you, okay? All right. So first we're going to start with level 1, and these are level 1 questions. These are level 1 laws. Now keep in mind, all of these laws can work with all of the levels. Okay, it's not just level 1, level 2, level 3, but remember I said that I was going to try to break it down so you can see what is expected of level 1, 2, and 3. Okay? So we have level 1 laws. So our first limit law, and this is level 1. I'm going to give the name of the limit law, and then I'm going to give you the actual law and then an example, okay? The name, the law, and the example. So the first one is called the constant rule, constant law. Constant, I think I spelled that right. Okay, thanks. The constant rule says that if we take the limit as x approaches a of some constant, so a constant is a number, a real number, could be fraction, decimal, square root, whole number, negative, positive, without a variable. Okay, a constant is a number without a variable. So like you know how when you did y equals mx plus b, b didn't have a variable, b is your constant. Okay, so the constant law says that if I take the limit of some constant, the answer, it's just going to be that constant. So for example, if I have the limit as x approaches 6 of 172, it does not matter what my a is. All that matters is the limit of the constant, and that is 172. Okay? Questions? Excuse me. Thanks. You don't have to write this down, but I want to show you what it is graphically. So let's say I have a xy coordinate, and this is 172. So this is y equals 172. And let's say a is here. Well, I said 6, right? So this is 6. What this means is that the limit from the left and the limit from the right still end up being 172. So some of you like to see this let me zoom in for you guys. Some of you like to see this graphically. So this is what it means. This is how we're connecting algebraic rules to the graphing limits, okay? This is what it means. So coming from the left and the right, they're the same value, so that means the limit is 172. I hope that helps for you to see it visually and then in math. Are there any questions on that one? I know it's just a quick law, but I'm trying to make sure that you understand it in the way you've seen it and then in numbers. Okay. The next one is called the linear rule, that timer in the way? I can't tell. No? Okay, thanks. The linear rule says that if we have a limit as x approaches a of x, the answer is a. But Miss Santana, how? Remember, we're talking about values as x approaches a, okay? All we're doing is we're substituting, going back to algebra, we're substituting in a for the x. We're substituting in a for the x. So if I have the limit as x approaches 3.14 of x, then that limit is 3.14. All I'm doing is taking the x value that's approaching and substituting it in for x. Am I going too fast? Are you sure? Okay. All right, let me show you that graphically. Oh no, my brown pen is running out of ink. This is y equals x. Am I off screen? A little? Is that good? Okay. Let's say this is 3.14. So I'm trying to look from the left side of the graph until I got to 3.14. Remember I drew this little line, which is here. And then the right side of my graph, 3.14. And then that will be 3.14. So that's what it looks like graphically. Okay, from the left, from the right, because they're approaching the same value, it's the same. Questions? All right, can I move down? Okay, thanks. Okay, now this one isn't really a mathematical law, but I included it so that we can access the material, so that this way we can remember how to substitute in for functions. So this is still going to be part of the linear. This is the limit as x approaches a of mx plus b. What's this look like? Hey. Yeah, this is slope-intercept form. PTSD. Oh, we've got linear stuff coming up in a couple weeks. Okay, ready? So PTSD. Oh my God, I'm dead. Not PTSD. So what you're doing is you're going to be substituting in for x. Okay. Remember, this says x approaches. You don't want to substitute it in for m or b. Don't want to substitute that in at all. So it's going to be ax plus b. Nope, did that wrong. See, I did the thing that I said for you not to do. My bad. I got too excited. M, sorry, can you see that? Or no? Okay, thanks. M times A plus B. So whatever that value is going to be the limit. So we have the limit as x approaches, I'm just going to say 1 of 3x plus 1. So I'm going to substitute it, 3 times 1 plus 1, and that's going to be equal to 4. I almost put 5. My brain is not braining. Okay. When you're done writing that down, take out the example sheet. We're going to do the level 1 examples, and then we're going to flip over and do them in our groups. Thanks. All right, ready? Okay. So you should be looking at the example sheet and up here. Again, we need to just all write them in the notes because there's not going to be enough space on your sheet, okay? So this is level 1 examples. level 1, number 1 says to calculate the limit as x approaches 6 of 7. Now, I'm going to tell you this, seniors. In the years that I have been teaching calculus, in the years that I've been teaching stuff like this, I see the same mistake over and over and over again, okay? And I'm letting you know what this mistake is now so that hopefully you don't make it, okay? Excuse me. This, a lot of students are writing 6 as your answer. You cannot do that. You cannot do that. This is not the value that we are substituting. We're not looking for what happens, or we're not looking for 6. What we're looking for is what happens at 6, where your value is approaching, what the value is getting close to at 6, okay? This does not change. It is a constant, so it remains 7. I guarantee at least one of you, I'm hoping nobody actually, at least one of you is going to put 6. Don't put 6. We're looking for just the constant, okay? Question? This one, so again, I'm trying to make level 1 attainable for everybody. Nobody should get any of these level 1 questions wrong, okay? Nobody, all right? There's no reason you should be getting a D in this class. Level 1 is attainable, unless you just don't do anything. Questions? Okay, all right, number 2. We have the limit as x approaches 2 of x. So all I'm doing now is I'm substituting 2 for x. I only have one x, so the limit is 2. Let me box my answers. Questions? See, level 2 or level 1, pretty straightforward. Number 3, the limit as x approaches negative 6 of 9 minus 8x. Okay, so now it's a little different. What should I then be doing with my negative 6? What should I be doing for a negative 6? It's okay if we don't know. What I'm going to do with this negative 6 is I'm going to plug it in. Oh, I should not say plug in. Sorry, that's not mathematically. Not math. Substitute negative 6 into this x. Okay? So it's going to be the 9 minus 8 times negative 6. And this is what you need your calculators for, because some of us can't do math in our head. No shade, but shade. That's 50. I don't even know. 48. 57. Maybe. Yeah? Okay. Yeah, go ahead. Double check. I'm pretty sure it's right. Because that's 48. 48 plus 9. Yeah. 57. What'd you say?
X is negative 6.
X is negative 6. So yes, we're going to take negative 6 and substitute it into there. Okay? Good question. I see some confused faces. Please ask questions. Please. Please. No? Are we good? Are we good on level 1?
Yes.
Are we sure? Should we have them try level 1 or should I move on with notes? Keep going. Okay. All right. Then on the back of the sheet, there are level 1 questions. There are 3 of them. Try them. We're going to give you 5 minutes. Yeah.
Do we write them down on the paper?
No, put them in your notebook. Put them in your notebook because you're not going to have enough room for all of them. Do we need the light on or can we see?
It's on.
We can see. Oh. Oh, yeah.
It's already.
Oh, yeah, he asked it, like at the beginning. Sorry.
This one.
After this, yes. Okay? We'll compromise. How's that? Oh, you know, you just write an equal sign. And give me the answer.
Is it like that?
Or like, yeah. Yeah. I'm standing. Oh, I didn't see it. Yeah, yeah, so these are the examples, so now I wanted you to try these two. Yeah. Yeah, oh, yeah, because I copied them, like I did them on.
Oh, those were the ones you did?
Yeah. Yeah. Here, here the notes. For the first part. Thanks. All right. Do you want to stop the timer? Sorry. It looks like most of us are done. Brian. Hernandez. What is the answer to number 1?
19.
Very good. 19. Joaquin, what's the answer to number 2? Negative 10. Very good. Viviana, what is the answer to number 3? 6. Bless you. Yes, 6. That is correct. How did you do that? Or tell me what's right. Just tell me what's right. You don't know? Christian? Oh. Yeah, 4 times 4. Minus 10. Okay. Questions? Good? Good, good. All right, ready for level 2?
Yeah.
All right. Now, I'm not going to lie. Level 2 has a lot of rules. Actually, this is for level 2 and 3, okay? Level 2 and 3. Level... Yeah. Paper or graph paper?
Either one, it'll grab paper.
All right. Level 2 and 3 have a lot of rules, but they're all intuitive, meaning that if you understand how to do basic like math, like addition, subtraction, division, multiplication, square root, cube root, it's pretty straightforward. Okay. Right now, level 2 and 3 get a little bit harder, but are still attainable. Okay. So let me give you the limit laws. Ready? Okay. Again, these should go all in your notes. So this is level 2 and 3 limit laws. We have like some rules that need to apply, bless you, before we make sure that these things actually happen. So in math, we always have to say something exists or something is true before we actually do the rule. So you have to make sure that both limits or all the limits of each of the functions exist. Oh, sorry, if. Okay. L1 and L2 are limits. So these are the things that we know to be true. I'll wait until you write this down because I want to point something out. Yes. Yes. Okay. I want to point this out. A couple things. These two things are different functions. F of x and g of x are going to be different functions, okay? They may be similar, but they're different. L1 and L2, these are the limits of these two functions. So limit 1 and limit 2 are the limits of these two functions. What needs to be the same is your a value. These two things have to be the same in order to use these rules, okay? These two things have to be the same in order to use these rules. If one is 1 and one is -3, you cannot use these rules, okay? Because we're not approaching the same value, so we don't know what's going to happen, okay? They have to be the same. Okay, so we have, are we ready? Okay, so first rule is the addition rule. Now, keep in mind I'm only doing 2 functions, but this can be with multiple functions, 3, 4, 5, okay? It doesn't matter. We can use the same rules for multiple functions. The addition rule says that if we have the limit as x approaches a, thanks, of f of x plus g of x, oops, can I move up right there? Okay. I can just split up the limits and add them separately. Sometimes it will be a lot easier for you to do this separately than together. You'll see what I mean in examples. Oops, off screen, my bad. So we can separate them and calculate them separately, but add them together at the end. Alex, you're next, right? So all this is going to be limit 1 plus limit 2. Limit 1 plus limit 2. Some of us looks confused. It looks confusing in mathematical notation. It does. But when we get to the examples, you'll see that it's really not that confusing, okay? B, subtraction. Oops, can't spell today. Oh, thank you. Subtraction is the same as addition, except what's going to be in between the two things? A minus sign. So the limit as x approaches a of f of x plus g of x, oops, minus g of x. And now we just separate them with a subtraction sign. Now, someone has asked me in the past multiple times, does order matter? Yes, order does matter. Order matters. If your g of x comes after your subtraction sign, it matters, okay? 4 minus 2 is not the same as 2 minus 4. Okay? Keep that in mind. So then this one is going to be, or not to be, the limit 1 minus limit 2. right, multiplication. Am I going too fast? What'd you say?
Very
No.
good.
Okay.
Very good.
Multiplication. Multiplication. So what do you think we're going to do between the two limits? Thank you. Multiply. So the limit as x approaches a of f of x, g of x. Remember, if there is no operation between two things, the understood operation is multiplication. Okay? There's no operation between these two, so the understood operation is multiplication. So we just separate them using multiplication. I'm going to use a little dot, okay? And that's going to be equal to the product of the limits. Alejandro, I gave you the sheet, right? Okay. Do you need this? Okay, I'm almost done with it. All right, two more, and then we'll get to the examples. Oh, I went straight to D. Quotient. What do you think we're going to do?
Divide.
Divide. So we have the limit as x approaches a of f of x over g of x. Oh, sorry. That's going to be the limit over the limit. All right. So we'll have limit 1 over limit 2. Limit 1 over limit 2. No, not that one. What can you never divide by? What can you never divide by? Anybody? You can divide by all but one number. 0. We cannot divide by 0. So you have to make sure that L2 does not equal to 0. This is going to be level 4, and we'll get to that later. Okay? This is a level 4 thing. We'll get to that later. All right. We have one more. Then we get to the examples. One more and we can get the examples. Promise, 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 promise. Good? Can I? Yeah. I see some of us still writing. Was I going too fast? Was it going too fast? Yeah. No? Okay. Justin, let me know you're ready. You ready? No? Okay. Oh, man. Dude, you're going to have arthritis when you're 21.
What? No, I gotta say.
Oh, that sounds like it hurts. Ready? Ready? Okay. All right. Last rule is called wait, that was E, right? Not 5. The last rule is called thanks. Is called the radical rule. And not radical like cool radical. It means it's going to be a root. So like square root, cubed root, fourth root, okay? I don't think we're going to have time for them to practice level 2 and 3. I'd rather get through the examples and then tomorrow they can practice. Okay. The radical rule says if we have the limit as x approaches a of the nth root of f of x. For those of you who don't know, n is called the root. So cubed, fourth, fifth, sixth, 172nd. That's going to be equal to the nth root of the limit. This is the square root. Anybody know what the understood n is? What is n? Ooh, not 1. Not 1. Not 0. What is this? Go ahead. It is a root. What specific root? What do we call this? Square root. So what exponent is squared? 2. So the understood root here is 2. This is the one of the very few mathematical symbols where the understood number is not 1. Okay? All right? All right. When you're done writing this down, take out the examples so you can follow along. Remember, we're still writing the examples in our notes. Okay? Still writing the examples in our notes.
So those are all the laws.
These are all the laws, yeah. So these are going to be the laws for 2 and 3. Ms. Ravello, is somebody out?
Yeah.
Kevin, right? And then Christian. Oh, that was my bad. Sorry. We should just have them start writing them. All right. Are we? Oh, Justin. Sorry. Sorry, Justin. Am I going too fast? Okay. Oh, sorry. You did.
Yes.
Yeah.
What's the next step? Is that one gonna?
Friday's makeup. No, not for late. No.
Oh.
But right now it's a 0 and great.
Oh.
Okay. All right, let's go over the examples. We're on level 2. So number 1. So at the top, I want to show the difference between level 1 or level 2 and 3. In level 2, they're going to give you the actual limits. So these are the limits given. I'm going to give you the limits. I'm going to tell you that the limit of these functions is this. Okay? The limit of these functions is this. For level 3, they just give you the functions and you have to find the limit. Have to calculate the limit. Okay? We just give you the functions. Okay? Is that for you?
Yeah.
Okay. All right, so that's the difference between 2 and 3. So let's look at level 2. Level 2, the first one, is the limit as x approaches a of f of x plus 2 times g of x. Okay? Now, in order to excuse me. In order to get full credit, I do want you to make sure that you're splitting up using the rules, okay? So the limit as x approaches a of f of x. Am I going too fast? Are we sure? Okay. Plus the limit as x approaches a of 2gx. What does this 2 mean? I'm sorry, I heard somebody say. No, that would only be if it's a square root. But what does this 2 mean just in math? What operation is it? Multiplication. So what am I going to do to gx? Multiply by what? By 2. Okay? All right. So, what is the limit for f of x? Do we know? Do we know the limit for f of x? I don't know, Miss Santana. That's okay. We do know the limit for f of x. What is the limit for f of x? 2. So wherever f of x is, I'm going to put 2. Does that make sense? Yes? No? Are we sure? Plus 2 times the limit of g of x. What is the limit of g of x? Ooh, I heard 2 and I heard negative. So we have f of x, negative 4. Okay? So this is, here, let me do this. So we know, do you see that now? Okay. Questions? So all I'm doing is splitting it up and substituting in what I know. And that's going to give me negative 6. Right? Final answer? Yeah? Okay. Questions? We sure? Okay. Number 2. Ask me for the limit of h of x minus 3 times g of x plus 1. Okay. Oops, I forgot as x approaches a. So we have the limit as x approaches a of h of x minus the limit as x approaches a of 3gx plus the limit as x approaches a of 1. Sorry, did everybody have that first example? Did anybody not have it? All right, I'm just going to keep going then. So here we're going to be combining some rules that we have before, okay? So according to our little note, what is the limit of h of x?
0.
0. Very good. According to our note, what is the limit of g of x?
Negative 4.
So we have 3 times negative 4. Now, here is where we come to level 1. What is the limit as x approaches a of 1?
0.
Not 0. This is called the constant law. Not x.
1.
1. Remember, the limit as x approaches any constant is just that constant. Was that Brian?
Me.
Who was me? Oh. Right. And now you just simplify. You get 13, I believe. No? Yes. Okay. We have time for one more. And then we can finish up level 3 examples tomorrow. I'm going to, I think, probably skip to a harder one, Miss Ravello. Maybe number 5?
Yeah.
Okay, let's do number 5. Thank you. Okay, so we're going to skip to number 5. Number 5 is the limit as x approaches a of the cubed root of f of x. Okay. Oh, sorry. Plus 6, right? Uh, 6 plus f of x. Okay. So what that's going to be is the limit, or the cubed root, of the limit as x approaches a of 6 plus f of x. What is f of x? Yeah, what's 2? Oops, that's not what I wanted. Sorry, I'm trying to rush because we're running out of time. So 6 plus 2. What is 6 plus 2?
8.
Very good. Now, the bonus points if you can do this without your calculator. What is the cubed root of 8 without your calculator? Nobody.
6. No.
Nope.
6 plus 2?
Nope.
No.
Oh. Yes, 6 plus 2. All right. The cubed root of 8 is 2. Does anybody know how to put this in the calculator? All right, everybody grab your calculator. Hit math. If you go down to number, is it 5? It has the cubed root.
That's X.
No, don't use the x one. There should be a cubed root one.
Oh, yeah.
That's like 4. If you go to number 4, hit enter or hit number 4, you'll get the cubed root sign and then put 8 underneath, and there is your answer. We'll work more on the calculator stuff tomorrow.